What's happening at Great Salt Lake is actually part of a bigger problem in the West. Particularly in the Southwest, we're experiencing what's called a mega drought, and that means there are signs in these climate parameters that are being measured, things like tree rings, for example, that we are not just in a couple of dry years, but that these dry years could last a decade or two. And so we really need to be careful during this time period. We're also experiencing the pressures of climate change. So that all taken together, start to pay attention to what's happening in the Western United States. We are seeing other lakes dry up, Lake Mead, Lake Powell, for example. And this is for the same reason, for water diversions that have happened that have put us in a situation where we can't meet the challenges that we need to right now with climate. So again, people really made decisions that set this up, and we need to reverse some of those decisions and respect natural watersheds. And that is one way to deal with these water problems in the West. I like to say we've done this experiment before. So there's a great experiment we did, a great example that we did where we actually created a human health hazard and then returned it from that. And that is the example of Owens Lake. So back in the 1920s and 30s, there was a company in Los Angeles that has the best name, LA Water and Power. And LA Water, they had the water and they had the power. And they decided to build an aqueduct to drain a whole lake called Owens Lake and to bring that water for Los Angeles to have water, because the Los Angeles population was growing and they wanted it to grow. They wanted people to be attracted and come there and work. So they said, we'll just take this lake that no one's using and we'll build an aqueduct and we'll take this straw and we'll suck all of the water to LA. Well, what happened is they did indeed get the water in some pretty wild dealings, and they were able to bring the water to Los Angeles, but Owens Lake dried up. And then Owens Lake became the worst air quality disaster that this nation has ever seen. They started measuring the particulate pollution at Owens Lake, I think back in the 1950s and 60s, and it just kept exceeding all of the air monitors. And so they thought, well, how do we fix this problem? So now LA pays part of their water bill every month. Everybody in LA pays 20% of their water bill every month to buy water to sprinkle on the lake bed at Owens Lake. So how do you fix the problem? You put water back. That's the experiment. And so I like to point to that because humans made these decisions. I'd rather have this water over here. Let's move it. And then they're like, oh, that caused a problem. So now we need to put some water back. And we don't want to get that far with Great Salt Lake, right? We already know what's going to happen if we keep sucking water from Great Salt Lake and it keeps shrinking. We know what's going to happen. So let's put some of the water back, right? We've done that experiment. That is an experiment about drying the lake. There's another experiment that's been done about making it too salty. So around 1960, folks built a railroad across Great Salt Lake. It was already there, but it was on a bridge where the water could flow underneath it. And then the U.S. railroad companies made the railroad stronger, and they supported it with rocks in the causeway. And that caused the north part of the lake to be completely cut off from the south arm of the lake. And now the rivers all come into the south part of the lake. And up here in the north, you don't get any of that input from fresh water. So the only fresh water you get is from precipitation. And so that part of the lake has become so salty that we measure 34% in the summer. It is so salty. It is as salty as water can be at that location. What happened to the ecosystem when it got too salty? The microbialites died. We've done work on the old microbialites that are there. There's no cyanobacteria. So the microbialites died. there's no brine flies. If you see brine shrimp there, it's because the cyst blew over there. They hatch, but they don't thrive. They don't reproduce. So the invertebrates don't do well. There's no algae in the water column. There are a few species of algae that can handle that high salinity, but they don't make great food for the brine shrimp. So the whole ecosystem changed. So we've done that experiment. We've taken Great Salt Lake itself and we've made a part of it too salty and asked the question, what happened? Well, look what happened. We killed both food chains. So let's not do that again, right? Let's not make the lake too salty. We know what will happen.
I'm Carly Beadle, and I'm the coordinator for Great Salt Lake Institute at Westminster. We have recently learned and observed that the flies in Great Salt Lake are declining, both in their size, but also in their population numbers. So I have created Team Fly, which is me and a couple of students and some other experts in the field who have been teaching us about the specific brine fly that's in Great Salt Lake. So we're trying to gather as much information in that part, but then also different methods to experiment on them, both in the lab and at the lake. So we are just starting out our lab research, but there have been similar experiments done in California with different amounts of saltiness in the pond, different salinities in different ponds. And the flies are smaller, they are less nutritious, and there's less of them hatching when it's super salty. And that super saltiness that was observed is what the same exact amount of salt in the lake right now. So that we haven't seen anything yet, but we're hypothesizing that that's what we're going to find when we run our similar experiments. It feels really exciting for me, being somebody who's new in the lake world, to be able to do this research and do something that actually matters, where we're trying to spread the word about what's happening in the lake. And to do so, we have to go to the lake and experiment and look at all the different organisms. And so being able to be out there, it's sad and it's hard, but being part of the solution feels really hopeful from the science side.
Hi, I'm Dr. David Parrott. I'm the Assistant Director of Great Salt Lake Institute, and I'm a microbiology professor at Westminster College. I study the plants that grow on the shore of Great Salt Lake. And there aren't very many. It's a pretty salty place. Plants don't like salt. In the wintertime, when we salt our roads, plants die in the spring because of all that salt. So you can imagine that someplace super salty like Great Salt Lake is really, really harsh environment. Only really extreme plants can grow there. So there are two main plants that grow on the shore. One is called pickleweed, call it Salicornia, it's its scientific name. And the other one is called Sueda. And both of these have adapted over a long period of time to grow in this really, really salty environment. Pickleweed is called pickleweed because it tastes like a pickle. It's really salty. It's got kind of a sweet, pickly kind of taste to it. And so it has a way of sucking salt into its cells and then getting rid of that salt. The Sueda does something similar. These two plants, though, are really kind of weird because they don't get foraged on very much by any kind of animals. There aren't a lot of things that eat these, and so they're not really a food source for anything. Sometimes they can provide a little bit of habitat or cover for smaller birds that are walking around the shoreline, but nothing really forages on these. So they might actually make a good candidate for covering open bits of lake bed because they wouldn't be eaten by anything that's out there. What I'm really interested in is seeing how much movement there is of these microbes that grow around the roots of plants as the lake recedes, and see if we can start understanding who needs to be around the roots of plants. So we could start maybe seeding the dry lake bed with plants and with natural plants, the ones that grow around the lake, so that we could try to mitigate dust. And that might be something that is a possibility. We just don't know quite yet. Some more research to do.
We started Great Salt Lake Institute about 15 years ago, and we thought that there was a need to propel some of the research forward that really wasn't being done on the lake. And if we started an institute, could we collaborate with people to answer all of these scientific questions that weren't being answered? And once we got into it, we realized that there was also a need to pull in artists and writers and people in business. And Great Salt Lake Institute then started to become very interdisciplinary. And that has been really fun for me because I get to learn where science meets lots of different things. So we have a couple of words that we use a lot at Great Salt Lake Institute, and one of those is collaborate, and one of those is synergy. We like it when we work with someone and it turns into something bigger than it was before. We were doing lots of science research out near the Spiral Jetty, the artwork built by Robert Smithson in 1970. And we were there because of the science, because the microbes in the water there and in the soil there are really interesting. And so we're doing science there. And it turns out that the folks who owned the artwork, Dia Art Foundation, they're in New York City, and they just don't have people on the ground to help manage that land art. And so we said, well, we'll help with that. So we started working with them, and we would call them back in New York City and say, hey, there's a lot of trash out by Spiral Jetty. Could we help you by taking our students out? And then it turned out that they started coming out to visit Spiral Jetty with us. And then they started hosting us to go back to New York City to talk about the science at Spiral Jetty. And then they had to do things like negotiate a land lease, and they had to do things like deal with people who wanted to drill oil out near Spiral Jetty, and we could be their advocates on site. And so spending time with artists really changed the way that we were doing our science. And then we wrote a grant for artists and scientists to work together. We called it SALT, Scientists and Artists Learning Together. Isn't that cool? And then we were able to do undergraduate research with students in the summer with our students at Westminster College, where we had art students and science students working together on a project. And it was so cool. So you can take like something that is a simple phone call, and it starts as a relationship of, yeah, I'll tell you when there's trash at Spiral Jetty, and you can turn it into this like beautiful collaboration. There is a really interesting collaboration that we had with an artist who does photography, and she uses infrared film to capture not just the image of the bird, but sort of the feeling of the bird. And so this is really slow film, and the photographs tend to be kind of grainy and interesting, as opposed to something that is sharp just to get the bird's features. She wants to get the bird's expression. Super interesting. We learned about her work because she was doing an exhibit at the local Natural History Museum of Utah. And we met her and invited her to come be our first artist in residence, actually. And so she stayed at Westminster and spoke with our students and worked with us. And what I learned in that time was that when she was in college, she had studied pelicans in Florida. And these are brown pelicans that live in Florida. But in Great Salt Lake, we have this really unique circumstance where we have 85,000 pelicans that nest on an island in the middle of the North Arm. And you may be saying to yourself, but hey, I thought pelicans ate fish. And hey, I didn't think fish lived in Great Salt Lake. And you would be correct on both accounts. And it turns out that when these pelicans come here to this breeding colony to make babies, the babies hatch, and then the parents fly like more than 100 miles a day to go get fish and bring it back to their babies. And this is not usual behavior for a pelican. Usually pelicans live where there are fish in the water, and they just kick their babies out into the water and teach them how to catch fish. So it's a very unique pelican colony, and the second largest breeding colony for American white pelicans in the world is in Great Salt Lake. So that's a wild story. I think photography can bring a lot to the studies of Great Salt Lake and to science, because you can show what's going on. We have cameras hooked up to our microscopes. We can even look at what's going on at the microscopy level, all the way up to what's going on to the birds. And I even used recently in a paper aerial footage of Gunnison Island to see how it had changed over time. Well, I don't have an airplane and I didn't take those pictures, but the state of Utah has been taking pictures above Gunnison Island to monitor the pelicans since the 1980s. So I was able to get access to these photographs, and they tell a story about when Gunnison Island was flooded all the way until when Gunnison Island is no longer an island. Now it's dry and you can only access it with an ATV. So it's a protected breeding ground that only the state officials can go to, but now they can't take boats to get there. Photography told us that story. So we like to collaborate with people to help get more work done on the lake, but we also like to collaborate with nonprofits and advocacy organizations that are doing really important work. And this brings me to an important point, which is we have found a role in communicating with all the scientific agencies for the state that work on the lake. It's really important to be able to have good partnerships with folks who work in government, for example, who manage the lake. And really, as the lake has started to go into crisis, as the elevation of the lake water is shrinking, I have found myself talking to legislators, which I never thought as a scientist that would be part of my job. But people call me and they ask, as a scientist, what do you think would be the best way to move forward on this initiative? And they're actually asking my opinion. And I think it's really important to find a way to bring your voice to political issues, because the government is for us, by us, and we need to raise our voices. And so if I have knowledge as a scientist and I only tell other scientists about that by publishing scientific papers, I don't think I'm doing a good job for society. I think I need to bring my science to the public, and maybe that is to inform state agencies. Maybe that's to inform legislators. Maybe that is to speak in an assisted living facility or at a high school. All of those things are important, and talking to people like I'm talking to you right now is really important to me as a scientist, because science shouldn't be in a box that's unreadable by most people.